For problem 22, we do have to draw the two curves y is equal to x cubed and y is equal to x, and then find the area between them. So let us draw our axis. And we'll draw x cubed, so it goes 0, 0. This is 1, this is 2, 1/2, and so on. So just that we could see the behavior of this curve in a smaller scale. So we do have the point 0, 0, 1, 1, and now 1/2 cubed is very close to 0. It's 1/8. So it goes, there's an upwards concavity until 1, and then from there it just keeps growing without bounds. And let's do the same for the other side. At x is equal to -1/2, we are going to have about -1/8. Let me just erase this so it doesn't get too messy. And then at -1, it's going to be -1. Oops. It will go something like this, yeah. And this is how it grows. So now that we have the curve y is equal to x cubed, let's draw the line y is equal to x, which is just a straight line that passes from 0, 0 to 1, 1 to -1, -1. So it should be something like this, yeah. Now we can see that the area between these two curves is this area over here and this area over here. So what we're going to do is, because these two areas are symmetrical, they're the same, and the reason that we know they're the same is because both the curve y is equal to x cubed and y is equal to x, both of them are odd functions, which means that they do have symmetry across the y-axis. So really what we're going to do is we're going to calculate 2 times the integral from 0 to this point where they intersect. Now it does appear that this point is 1, but it's always good for us to analytically check it. So let's just set these curves equal to each other. So x cubed is equal to x. We'll bring everything over to the left and factor it. So this is x cubed minus x is equal to 0. So x times x squared minus 1 is equal to 0. And x minus 1, x plus 1. So we can see that they do have 3 points of intersection at x equals 0, at 1, and at -1, which does correspond to these points over here. So we do know that 0 is going to be the lower boundary. So this is the integral from 0 to 1, which is the upper boundary. And as previously mentioned, we're going to do 2 times the integral from 0 to 1 so that we can avoid integrating from -1 to 0. And once more, we're doing this because the areas are the same. So now we just have to set the upper function minus the lower function. The upper function is the one in green, so it is x minus the lower function, which is in blue, x cubed, and all of this times dx. So now we just take the reverse power rule and apply our boundaries. So this is 2 times x squared over 2 minus x to the power 4 over 4 from 0 to 1. So that is 2 times, so this is 1/2 minus 1/4. We're not going to apply the lower boundaries because it would just be 0 minus 0. So this is equal to 2 times 1/4, which is really equal to 1/2. So here we have that 1/2 is the area between these two curves. So all we had to do was draw it and then see that we arrive at symmetrical areas, so we can just take twice the area from 0 to 1.